Hi everyone, in this video I'm going to briefly discuss our home planet, fun ride and its death orbit in cosmos. Before I start this video, please remember Earth is truly taking us on a wild ride, hurtling through space at a tremendous speed. Our planet is extremely dynamic. For example, Earth spins on its axis which gives us day and night. Earth also goes around Sun, which gives us a year. In addition, our Sun, with its planets, orbits around the center of the Milky Way galaxy, which is called a galactic year. It is not over yet because our galaxy itself buzzing through space, never a boring moment for our planet in space. We are simply Earth's passengers while our home planet is traveling through cosmos. We don't feel anything, and for us everything looks calm. However, it is not the truth. Our cosmic journey has so much of interesting information to share, therefore let's get into it. Let me talk about Earth's spin on its axis. Earth rotates on its axis roughly 23 hours and 56 minutes, which gives us a day and night. All lives on Earth evolved with day-night cycle. Therefore, it's ingrained in all organisms. Life evolved with Earth's orbit. Coral reefs in oceans will teach us a lot more about Earth's orbit. Coral reefs register day-night activities of Earth's rotation. There are coral growth bands, they call it, which records daily cycle. By counting the growth bands, we can count the number of days in a year. Guess what? When scientists studied an ancient fossilized coral over 100 million years, they found that Earth in the past has had roughly 420 days per year, meaning a day on Earth was about 21 hours. To understand this, we need to go back in time of Earth's creation. Roughly about 4.6 billion years ago, our planet went through dangerous passage of time with chaotic collisions. There were collisions during the planet's formation, and one of them was truly a giant one which led to the formation of our moon. I have a video on how our moon may have formed, provided the link below if you want to watch it later. Every collision adds speed to the rotation because 90% of the impact were always on an angular motion. It is like how a speed increases when a kid jumps into a merry-go-round. While it is moving, as kids start pushing, the rotation increases, which is the same thing happens when Earth gets bombarded with angular motion of impacts. Earth rotates much faster, which is 12 times faster than what it's today.
I want to discuss about the Coriolis Effect, which affects rotation. Speed of Earth's rotation impacts weather. With shorter days in early Earth's formation, there should have been heavier storms, winds, and tidal waves. These phenomenons exist on the Earth today, and we call it the Coriolis Effect. What is a Coriolis Effect? It is a natural event in which objects seem to get deflected while traveling around and above Earth. The planet Earth is constantly rotating or spinning from west to east. Every 24 hours, it completes a full rotation. Earth's spin creates a phenomenon in Earth's atmosphere and oceans. The rotation smashes with sun's heat energy and causes air to move north from the equator and sideways to compensate the Earth's spin. The young Earth was spinning fast and was creating hectic storms and high wind speeds. It is very difficult to theorize whether the life that we know of would have survived. However, our planet's spin was reduced by our companion moon. There is a wonderful dance between the moon and the Earth, which also created a bulge in the center of the planet. The moon's gravity pulled Earth's oceans and generated tidal bulges, which slow down Earth's rotation speed. The bulges acted as a friction to slow down Earth's rotation. Tides also helped create life. Giant tides swept nutrients from land to oceans. A primordial soup began to brew, and life arose with sun energy. As Earth rotation continued to slow down, life spread across the globe. Our planet's spin is only one part of Earth's voyage in space. Here are some additional facts about Earth's spin and some interesting information about the Sahara Desert. Earth's wild ride through space may have caused once tropical and lush land Sahara turning into the driest place on Earth. The desert is dry, dusty, and desolate now, but hidden deep in the desert's caves gives clues that it had a different life thousands of years back. The Sahara was lush, green, and paradise. Archaeologists have discovered several art caves where ancient people swam with animals in lakes. There are also satellite images confirming ancient river valleys and fossilized trees. At the time of Earth's formation, many objects collided with our young planet. Astronomers believe there was a Mars-sized object impacting Earth and completely tilting the planet 80%. Our planet continued its journey tilted, but the moon's gravity pulled us up, but not completely. If you watch the night sky, you can see that the moon is not in the Earth's equatorial plane. It is above the equatorial plane and pulls the Earth's axis into a 23.5 degrees tilt. This tilt gives seasons for northern and southern hemisphere of our planet. These seasons that build our atmosphere in conditions for all sorts of life across the globe. But the tilt doesn't explain how the Sahara became a dry desert. Now this will explain, because all the clues are on the North Star Polaris. Right now, the Earth's North Pole axis is pointed at a star, which astronomers called the North Star, and named it Polaris. However, Polaris has not always been the North Star, and will not always be the North Star. About the year 3000 BC, the North Star was called Thuban, also known as Alpha Draconis. And in about 13,000 years from now, the precession of the rotation axis will mean that the bright star Vega will be the North Star. Don't feel bad for Polaris, however, because in 26,000 more years, it will once again be the pole star. This happens because of North Pole changes. To understand that, we need to look at how the Earth spins on its axis. The spin axis of the Earth undergoes a motion called precession. If you have ever watched a spinning top, you know that its spin axis tends to stay pointed in the same direction. However, if you give it a slight nudge, the axis will start to change its direction, and its motion traces out a cone. This changing of direction of the spin axis is called precession. Something gives a nudge to the Earth, and what gives it that? The Earth bulges out at its equator, and the gravitational attraction of the Moon and the Sun on the bulge provided the nudge, which made the Earth precess. It was the ancient Greek astronomer and mathematician Hipparchus who first estimated the precession of the Earth's axis around 130 BC. The period of precession is about 26,000 years. In other words, it takes 26,000 years for the axis to trace out the cone one complete time. As Earth continues its voyage around the Sun, the wobbling motion changes the planet's climate dramatically. When the northern pole leans toward the Sun, northern hemisphere summers are sunny with unexpected consequences to the Sahara. It turns out the climate in Sahara gets more sunshine and increases its climate. The winds coming from the ocean, the monsoon effect, brings rain into Sahara. Now it's dry because of the 26,000 years cycle. So technically, stronger monsoon equals greener Sahara. All the cave paintings of the Sahara were about 10,000 years ago, where migrants settled in lush Sahara.
Stay tuned for part 2, where we will discuss Earth's orbital passage around its parent star and our solar system orbiting its galactic center. I hope you enjoyed Earth's spin. Thanks for watching. It is our home planet and more to come. Please subscribe and share this video. Thanks.